Welcome to the Math Record. Today I'll be starting chapter 1, which will be all about derivatives. In our last video, we said that the derivative is just a simplified version of our limit. That definition seems rather vague, so let's try to understand that better. So let's say we use an example. Let's try an easy curve. Let's use a parabola. So I'm not the best at drawing, so let's say something that looks like this. Okay, so let's just choose a point that's gonna be stuck in place. So let's say right here, and we're going to call this point x, so at some x value. And then we're going to have another point such that it can move around. So we have like a point that can move up and down this curve, basically. And we'll call this point x plus h. So if we call this graph f of x, then the y value of this, since this has x value x, then it's just going to be f of x. Now the y value of this point, which is x plus h, is f of x plus h. Okay, so in the first video in the series, I explained that the derivative is just some kind of slope. So how do we calculate the slope? Well, basically, we're just going to have the change in y over the change in x. So our change in y is f of x plus h minus our f of x. And our change in x is going to be our x plus h minus our x. So x plus h minus our x cancel the x's out, so we get left with an h. And now this formula might seem really familiar to people if you take in pre-calculus. So there is a portion of this formula missing, and the key word, as I said before, is that this point is really able to move. So when we're looking for derivatives, we're looking for tangent lines. So basically, we want to find a line that only goes through one point in the graph, right? So it only goes through this point. But if we choose a slope and it goes through this point and this point, then it's going through 2 points in the graph. Well, we don't want that. We only want through 1 point so we can find the derivative. So basically, what we could do is that since this point and this point has to be exactly the same, then we need to get h to 0. So all we have to do is just add a limit. So I drew this a little bit too close to the axis. So we're just going to have to add a limit as h approaches 0. And this formula is going to help us find the derivative. Well, we're going to use this formula in the next video. Well, thanks for watching.